Alrighty, here we go. We are going to start part 1 of our semester exam review. My goal here is to hopefully maybe get through the first 16 problems, but we will see where we go. Keep in mind, guys, I want y'all to be able to work on these on your own. So this video here is to kind of help you remember things, but see if you can have done these problems on your own first. Okay, so let's look at the first few problems. Shall we? We shall. Alright, dropping stuff. Alright, let's move on. Okay, what? Just 1 second. So the first few, all you got to do is plug in the numbers and then evaluate. So come up with an answer. So I would make sure to, have everything written and ready to go before you start trying to plug in the numbers. That's just me, so you don't make little mistakes like a lot of y'all do. So you can see here, B is supposed to be -8. A is supposed to be 2.5. And now you could actually type this into the calculator like as is, and I can show you how. There is a absolute value button that's available where you found the matrices, and you would get the matrix symbol. So, but anyways, this ends up being, let's see, -8 minus 5, which would be -13. So +13. The final answer should be -13. Okay, because this right here was going to be -13, and then you've got the absolute value of that, which is +13, but then you've got this negative that's in the front, which makes the final answer -13. And that's it. You just plug it in. Here I've got, for number 2, I've got 2 parentheses, -8 plus 6, close the absolute value, minus the absolute value of 2.5, and go like that. So this would be -2, but that absolute value of that would become +2. 2 times 2 is 4. So I end up with 4 minus 2.5, which is 1.5. Okay, and again, you should be able to type all of this right here into the calculator and get an answer. Alright, so number 3 is a wee bit different. Oh, this one says simplified. So this one actually is separate from the first two. The first two those two are the evaluate ones. So here I'm going to simplify. So 1/4 means divide by 4. So 12 divided by 4 is 3v. 8 divided by 4 is 2. Drop the parentheses. And then I'm going to distribute here. 2 times 6 is 12v. 2 times 1 is 2. And combine like terms. 3 plus 12 is 15v. -2 plus 2 is 0. So my final answer is 15v. And that's it. And there you go. Not too difficult, fairly easy. Okay, I'm going to write the next ones rather than try to take a picture. So number 4 says, okay, so the next ones we need to solve. So number 4 says 4x equals 18. All you got to do is what? How do I get rid of the 4? I divide. The opposite of multiplying is dividing. So you get 18 over 4, which in the calculator would tell you it's 9/2, and you're done. Number 5, 5x plus 2 equals 3x plus 24. Here, variables to the left, numbers to the right. If it's a positive 3x, it would become minus 3x. A plus 2 would become minus 2. That gives me 5 minus 3 is 2x. 24 minus 2 is 22. And then you can divide to get x equals 11. Okay, so again, little things that you should remember how to do should make that hopefully fairly easy. Number 6, there's quite a few steps here, but I'm going to try to squeeze number 6 in here because number 7 and number 8 need a lot more space on the next slide. Okay, so I've got this right here. I need to think, distribute, combine like terms, add or subtract, and then you can divide. Okay, so distribute, that gives me 2 times 4 is 8x. 2 times 6 is 12. Notice I didn't mess with anything else. Combine my like terms. These are my like terms right here. So that would give me 12 minus 7, which is 5. Okay, and then I'm moving that 5 over. If it's positive 5, it's going to become -5, which would give me 8x equals -32. Then I can divide by 8 to get x equal to -4. Yeah, and again, these are problems I feel like y'all should be able to know how to do. They're not too difficult. Just solving equations, and y'all should be able to do that. how is number 7 and number 8 different? Well, when you have an absolute value, 2 plus 3 equals 7. Okay, if the absolute value is by itself, like there is nothing outside of the absolute value, and I'll show you the difference between 7 and 8. Then you can drop the absolute value and say 2x plus 3 equals 7. Or 2x plus 3 equals negative 7. So you got to do the positive and negative. Now the steps would be the same. Subtract 3. And then you can divide by 2. 7 minus 3 here would be 4. But negative 7 minus 3 gives me a negative 10. So you see how the numbers are slightly different. Then I can divide by 2. So I'm going through the same steps on both sides. I'm just going to come up with 2 different answers. Here, 4 divided by 2 is 2. Here, 10 divided by negative 2. Negative 10 divided by 2 is negative 5. So put an OR. There's my 2 answers. Okay. I probably will try to make this a multiple choice test, just to let y'all know. But that doesn't mean that makes it easier. In fact, usually scores go down for me when I do multiple choice. Just keep that in mind. Okay, so x minus 2 equals 24. Now, what's wrong about this one is that there is a number outside of the absolute value. And so you need to get rid of it first. So this is times, so divide. You get absolute value of x minus 2 equals 6. And then you can drop it and say x minus 2 equals 6. Or x minus 2 minus 2 minus 2 minus 2 equals negative 6. What's the opposite of a minus? Plus. And then you'll have your 2 answers. So x is equal to 8 or x is equal to negative 4. And there you go. All done. Easy peasy. Not so bad, right? Right. Okay, so now let's move on to compound inequalities because y'all are so good with those things. So let's look at number 9. Number 9 says negative 10 less than or equal to 4x plus 10 less than or equal to 42. Okay, so on this type of problem, I like these because I always told y'all work from the middle. Okay, so the opposite of a minus 10, like if you covered up that left side, cover up that negative 10, what would you do? You would say minus 10. Minus 10. Well then, if you're going to do it on the left, do it on the right, then do it on the left. Be fair. Okay? So you get 4x less than or equal to, or in between, whatever. 42 minus 10 is 32. Negative 10 minus 10 is negative 20. Then you can divide everything by 4 to get x less than or equal to, or x is in between negative 5 and 8. Now, I wanted y'all to also graph these and show me interval notation. So here's an answer. The graph would be at 8 and negative 5. And you've got closed dots, so you got to remember when they're closed, when are they open, shade in between. Interval notation would tell you you've got negative 5, comma 8, and because these are lines underneath, those are brackets. So keep in mind, let me give you something here. So I will allow y'all to have like a note page, but be careful what you kind of can squeeze on there. Can't use your review, so kind of think about what necessary information. But you might have some inequalities where you have to worry about shade left, shade right, open dot, closed dots, shade in between, interval notation. How do you write it like that? Actually, I didn't do that on number 9, but I should have. Okay, and actually, I should have done 11 and 12 first before 9 and 10. I don't know why I haven't written like that, but that's just me being, I guess, a silly goose. Anyways, there's that, and you've got that information. So there you go. Okay, so now let's look at number 10. Oh, number 40, or number 10 actually gives you so much extra work, but okay, whatever. So let's distribute here and say that's 15x minus 35 less than 40. That's going to be plus 35, so that's going to give me 75. So I've got 15x less than 75. Divide by 15. So you should know how to solve these. X is less than 5. Okay. And then over here I'm going to add 9. to get 7x greater than or equal to 10. Divide by 7. I'm sorry, greater than or equal to 70. I'm already giving you the final answer. X is greater than or equal to 10. Okay, this is an OR. Now notice, if you look at the graph here, you've got 10 over here, you've got 5 over here. You're going this way with an open dot, according to the theme, and we're going to shade to the left. This one, you've got a closed dot, shade to the right. Now, interval notation, here's the interesting part. These two are separate interval notations. Okay, this one goes from negative infinity to 5. So in other words, it's like to the left. Remember, infinities were always in parentheses, and since there's an open dot, 5 is in parentheses. Or we've got, say, 10 going all the way to positive infinity. And on that one, again, parentheses here, but because of the closed dot, I've got a bracket. So kind of make sure you can understand those and kind of be able to repeat those. Now, like I said, 11 and 12 are the easy versions of these problems. I probably should have had those first, but I somehow messed up on my ordering. So same idea here. I'm going to add 5, divide by 3, and then I would get t is greater than 12. So on a number line, that means here's 12, open dot, shaded to the right. On the interval notation, I would put 12, comma, it's going to positive infinity. So like that, parentheses, parentheses, and you're done. On number 12, I've got 2 parentheses x plus 3 less than or equal to 54. You need to distribute, so you have 2x plus 6, multiply, less than equal to 54. Subtract 6. So 2x is less than equal to 48. Divide by 2. So we got a little bit of work here, and we can get 24. So here I have at 24 a closed dot that goes to the left, and going to the left is going to negative infinity. So my interval notation is negative infinity, comma, 24, bracket on the 24, but a parentheses on the infinity, because again, infinities always have parentheses. So depending on how I do this, you could be asked to give me an answer like this, like a graph, or like interval notation. So kind of keep that in mind. I can give you any one of those three and ask questions where I would ask you to give me some of these answers. All right, so let's look at 13 and 14. I'll do 13 and 14, and I think I'll be done because 15 through whatever kind of starts some similar stuff. So let's just do 13 and 14, and then we'll be done with part 1. Yay! I know, I try to be nice to y'all. All right. On these, okay, let's come back here. On 13 and 14, you have to remember there's great or less than. Okay, now what does that mean? That means that when you have greater, you're going to have, like, say, like an equation less than, or you're going to have another one that's going to be greater. And I'll show you what we do there. I'm sorry, I did that the wrong way. You're going to have one that's greater, or then you're going to have another one that's less than. And you'll see how those work. But less than, when you get the than, you're going to have something that's in between. All right, and you'll see what we do here. So like on number 13, you've got parentheses, or absolute value y minus 8 less than 4. Okay, so what that means is write y minus 8 less than 4, and since less than, that means it's going to be in between. It's in between two numbers. Well, one is 4 and negative 4. Okay, so when it's and, it's between the positive and negative. So I'm going to add 8 to solve. That gives me 4 less than, or y is between 4 and 12. Open dot on both. So that means the graph would be something like this: 4, 12, open dot, shade in between. The interval notation would be both numbers, but with parentheses since it's open dot. Okay, number 14 is a greater. Okay, because I got to say greater. It's more fun that way. Anyways, what does that mean? That means I'm going to say 2x minus 9 greater than 11, or greater 2x minus 9 less than or equal to negative 11. So notice it's positive, negative. You're going to have the same steps to solve with the same numbers. 2x greater than 20 divided by 2. That gives me x greater than 10. Or plus 9, I get negative 2 divided by 2x. So x is less than or equal to negative 1. Okay, so there is this answer. That means on the graph, here's 10 right here, here's negative 1. Closed dot at both, but the negative 1 goes to the left, the 10 goes to the right. And then the absolute value, or the the interval notation would be negative infinity to negative 1, bracket, parentheses, and 10 to positive infinity, again, parentheses, bracket. Okay, and that's part 1. If y'all have questions, feel free to ask. Hopefully y'all are making sure y'all are going to be responsible young citizens and try to make sure you have all this for me. Alright? Y'all are an awesome group. Thank you so much for all the time that y'all been doing. I know this has been a hard semester, but let's go. We're almost done for the semester. Y'all take care.